so 4.2, this is like the weird section in the chapter, and it's going to be treated by itself. So this first part of 4.2 is going to go over something called sigma notation, which is a new symbol for many of you. So it says the sum of n terms, A1, A2, A3, all the way up to AN, could be written with this symbol right here. Okay, and it's called the summation, or the sigma symbol of A sub I. And then as you work your way through, you're noticing the numbers go up. 1, 2, 3, all the way up to n. Okay, I is considered to be the index of summation. A sub I is the ith term of the sum. And then typically you're given upper and lower bound. So like it might be written as I equals 1 to n. So 1 would be the lower bound and n would be the upper bound. 1 is the first number that we see, and an is the last number that we see. Now, basically what that means is, like, if you look at example 1 with A, these aren't examples, they're just more samples here. But if we have the summation where I goes from 1 to 6 of I, that means I'm going to sub 1 in, I'm going to sub 2 in, I'm going to sub 3 in, 4 in, 5 in, and 6 in. And then what I'm going to do is I'm going to add up all those numbers. So that summation, that sigma symbol, basically just summarizes it into a single statement instead of all separate ones. A second sample is B. If I have the sigma symbol with k equals 1 to n, and then if I have the formula 1 over n times k squared plus 1, that means each term from 1 to n, now it says k, so I'm not substituting it in for n, I would substitute it in for the k value. So the first term I substitute 1, second substitute 2, third would be 3, and so on, all the way up to my last number where my upper bound is, which would be n. And again, that's just showing you how you would write it out. Now, there's 6 formulas that are associated with these. These are the summation formulas. I will tell you that you would be given these 3. The other 3, though, you should really know. So number 1 says if we have the sigma symbol with k and then times a sub I, well, k is a coefficient. It's a constant, so I could just pull that out. So it's k times the sigma of a sub I. 2 is that if you're adding or subtracting multiple terms, you just figure out the sigmas of each one separately, and then you add or subtract them. And then for 3, if you're taking the sigma symbol, or the summation of a constant c, it's the constant times whatever the n value is, which is your upper bound. And then there's 3 formulas here. 1 is if you have I squared, or I, sorry. 5 is if you have I squared, and 6 is if you have I cubed. And there's 2 types of problems that you're going to see in this section. It's either going to ask you to write a formula, or it's going to ask you to evaluate. So if you're asked to write a formula, you're going to have n's left in your answer. If you're asked to evaluate, then you're going to get it down to a single number. All right, so example 2 says we're going to find the formula for the sum of n terms. So that's what I mean for part 1. So you're going to write an equation. So the first thing we're going to do is, if I see what my equation is, well, I notice it's I equals 1 to n. So I is the value I'm subbing it in for, which means that this n squared is not really relevant. So I'm going to pull that out as like a leading coefficient. So I have 1 over n squared, summation, I goes from 1 to n of I plus 1. Okay, so that's property number 1. Next thing I'm going to do, I'm adding. So what I'm going to do is I have 1 over n squared, and then I'm going to take the sigma of each term separately. All right, now this is where the formulas come in. So I already used property number 1. So now if I have the sigma from I to 1 of n of just I, that's number 4. So I'm replacing that with the equation for number 4. Should be a 1. And for the second part, that's the summation of 1. Well, 1 is a constant, so this is property number 3. So then this would be 1 times my upper bound, which is n. And to be honest, you don't even need the 1. then what you want to do is you want to start to get stuff together. So if I have 1 over n squared, then I have n squared plus n over 2 plus n. I need to get common denominators, which would be a 2. So if I add a 2 there, I add a 2 there. So then I have 1 over n squared, 2 in my denominator, and n squared plus 3n in my numerator. I get n squared plus 3n over 2n squared, and then they all have an n in common. So I have n plus 3 over 2n. So if you're asked for a formula, this would be your formula, and you'd be done. Okay, so that's part 1. But then you're asked to evaluate it. So if you're asked to evaluate it, that's the easy part. So if n is equal to 10, you just take your formula and you plug 10 in. And if you're asked to evaluate it at 100, you just, again, take the formula and you plug in 100. So for 10, we end up with 13 over 20. And for 100, we end up with 103 over 200. Okay, but be able to come up with that formula and make sure that that formula is completely simplified when you do that. All right, example number 3 is not even asking for a formula. It just says use the properties to evaluate. So it's not asking anything in regards to writing out a formula. We're just evaluating it. And how you know you're evaluating it is if you look at the sigma symbol, the top number, it's not an n anymore. It's a 10. So if you knew that it was an n, then you wouldn't be able to evaluate it. But now we can. All right, so here's our formula. First thing I'm going to do is distribute that I. Then I'm going to use my properties, property number 2, and I'm going to split it up. So I have I to the third, I, and then I'm going to be using property number 4 and property number 6. So the first one is property number 6. So that sigma from I equals 1 to 10 of I to the third is n squared times n plus 1 over 2, 4. There's my formula. For I, that's number 4. So I'm going to first write out my numbers in terms of an equation. That would be 2. Okay, and then the thing is we have to, because we're evaluating it, we have to know what n is. Well, the way you figure out what n is, you do your upper bound. So it's upper minus lower plus 1. So 10 minus 1 plus 1 gets me 10 for my n value. Okay, so don't just always expect it to be whatever the higher number is, because if the lower number is not 1, that's going to change stuff. So now I sub it in. So I have 10 squared plus 11 squared over 4 plus 10 times 11 over 2. This first term is 3,025. Second term is 55. And when I totally evaluate, I get 3,080 for that one. So again, these are the key formulas that you're going to be using. You just have to figure